Okay, so on this lesson, we're going to be solving radical equations. We're going to be looking at square roots and also cube roots, which we have been looking at whenever we were doing the transformations. So solving a square root equation algebraically, you're first going to isolate the radical, if possible. And then to get rid of that square root, you're going to square. Whatever you do to one side, you must do to the other. You're going to square both sides. You're going to simplify and solve. You're checking for extraneous solutions, which we've talked about before with absolute values. Extraneous solution means you work it out correctly, you get an answer, you plug it back in, but it doesn't work. So raising both sides of an equation to the same exponent, such as squaring, may result in extraneous solutions, which are answers that appear to be solutions but are not. Identify extraneous solutions by verifying potential solutions in the original equation. So you're going to plug into the original equation to make sure that it's true. Okay, so we're going to solve and then check. So first thing I like to do is circle the radical. So I'm circling the radical piece. That means I need to get rid of the 1/3 in front, but also that plus 4. You always add or subtract first. So I'm first going to subtract 4 on both sides. I'm not finished because I also have to get rid of the 1/3. So we've talked about this before. To get rid of a fraction, you flip it and multiply. So I'm going to multiply both sides by 3. So that way it gets rid of that. And then once we get to this point, once I've isolated the square root, then I can square it. And whatever I do to one side, I must do to the other. So remember, we talked about this before. Anytime I have a square root and I square it, it gets rid of the radical. So all I'm left with is x plus 4 on the left side. 3 squared is 9. Now I have a linear equation that I can solve. So I'm subtracting 4, and I get x equals 5. Now, you have to check for extraneous solutions to make sure that it works. So I'm going to check it. You can also just plug it in the calculator. So that's going to be square root of 9. Square root of 9 is 3 times 1/3 is 1 plus 4, which does equal 5. So make sure that it's true. Again, you can use a calculator. I don't really care on that part for checking. Okay, so let's look at part B. Notice part B, we want to look at our radical. Notice it's already isolated. So since it's already isolated, I can go straight into getting rid of that square root by squaring. So I'm squaring both sides because whatever I do to one side, I must do to the other. So that gets rid of the radical on the left. Now, this is a common mistake right here. Remember when we discussed this before, a binomial squared is always a trinomial. So make sure you write this out twice to work it out. So we need to use FOIL. So that would be x squared minus 10x minus 10x plus 100. So the right side is x squared. Combining the x's, you get negative 20x plus 100. So make sure when you square a binomial, you should get a trinomial after you combine your like terms. So now I have a quadratic equation that I need to solve. So I'm going to set it equal to 0. Doesn't matter which side you move everything to. And then I'm going to solve it. Now you can use whatever method you want. You can graph it, find the roots, you can factor it, you can use the quadratic formula. Remember, the quadratic formula is the one that works every time. So your choice, you can do whatever you want. So if I use the quadratic formula, that's going to be 22 plus or minus the square root of negative 22 squared minus 4 times 1 times 105 over 2 times 1. Okay, so we discussed this before. We need to make sure that we plug in what's under the square root without the square root. And also remember that you need to put negative 22 in parentheses. So when you do that, you should get 64. Square root of 64 is 8, so you would have 22 plus or minus 8 over 2. So finding those two answers, you get 30 over 2, which is 15. And then 22 minus 8 would be 14 divided by 2, which would give us 7. So we get two answers here. We need to check it. So again, I don't care if you use a calculator when you check it. The square root button is second x squared if you don't know. So we need to check each one separately. So that's going to be 30 minus 5, which is 25. Square root of 25 is 5. 15 minus 10 is 5. So that one works, 15. And then we need to plug in the 7. So notice that right side is going to be a negative, and we automatically know a square root is not going to give us a negative answer. So the only solution here would be x equals 15. So very important that you're checking. Okay, so let's look at another one. So this one, look at your square root. Notice it's already isolated. So we're going to go straight into squaring it to get rid of it. And I'll do the same thing to the other side. So that leaves me with 5x minus 7 equals 3x plus 11, because I also have a square root on the other side. So now what I need to do is I need to solve it. This is a linear equation, so I need to move the x's to one side. Doesn't matter which side. That's 2x minus 7 equals 11. So then add 7. You get 2x equals 18, so x will equal 9. So we need to check it. So if you're checking it using a calculator, make sure you just type one side in, press enter, type the other side in, and make sure that they're equal. So that's 45 minus 7, which would be 38. So square root of 38. And then you would get 27 plus 11, which would be also 38. So square root of 38 does equal the square root of 38. So x equals 9 is the correct solution. Okay. Let's look at part D. So notice here that I have a radical on both sides, so I can't actually get rid of that because it would just put it on the other side. So I need to go ahead and square both sides. So right here, I know the right side is just going to be x plus 2. That's not the case on the left side. You can't just square this and square the 1. Can't do that. I'm going to have to use FOIL. So using FOIL, that's going to give me x minus 5, because it's a square root times itself. That gives me 1 square root of x minus 5. Gives me 1 square root of x minus 5. And 1 times 1 is 1. So combining your like terms, I'm going to have an x. Combining the constants, that's negative 4. Combining these radical pieces, remember we discussed before, you're just adding the coefficients, so that's going to be 2 square root of x minus 5, and that equals x plus 2. So now I only have one radical, which helps because I want to isolate it. So I want to subtract x and add 4 to both sides. So that cancels, that gives me just a 6. And then I still have to get rid of the 2 by dividing it. So that's going to be square root of x minus 5 equals 3. Now I can get rid of the square root by squaring both sides. That leaves me with x minus 5 equals 9. So I add 5 over and I get x equals 14. So I have to check it. So 14 minus 5 plus 1. So that's square root of 16. That's square root of 9 plus 1. So that's 3 plus 1. And that's 4. So that does work out. So x equals 14 is the correct solution. So that is solving a radical equation or a square root equation. Make sure you're always checking for extraneous solutions. Again, I don't care if you use a calculator to check. Okay, so next part. Now we're going to be looking at another type of radical, but this time it's going to be a cube root equation. So to solve a cube root equation, you're using the same technique as square root. So in order to get rid of a square root, we square it. So in order to get rid of a cube root, you would need to cube both sides rather than squaring it. So I want to do the same thing as I did at the top, and I want to isolate the cube root. So notice I have a 5 that I need to get rid of at the beginning. So I'm going to divide both sides by 5. And so that leaves me with cube root of x minus 1 equals 5. So now I can go into cubing. So that's just going to leave me with x minus 1, because if I take the cube root and then I cube it, it gets rid of that. So that's 5 times 5 times 5 is 125. So when I add 1 over, I get 126. Make sure you check it. Again, you can use a calculator. The cube root button on the calculator is under your math button, and it's number 4. If you want to use a calculator to check it. So that's 5 cube root of 126. So that's cube root of 125, which is 5 times that 5 in front. So that does equal 25. Okay, last one that we're going to look at. So we want to isolate the cube root. So first step would be to subtract 9. So make sure your radical is always isolated if possible. Now I can cube both sides. So that's just 4x minus 1. 1 times 1 times 1 is 1. So I add 1 and I get 2 on the right side. I divide by 4 and I get 1/2. So checking it. So half of 4 is 2 minus 1 is 1. So cube root of 1 is 1 plus 9 does equal 10. So that is correct. Okay, so these are solving radical equations. We looked at square root equations and also cube root equations. Let me know if you have any questions.